Next set of problems here is converting some different types of units. We have cubic centimeters to liters, grams to kilograms, seconds to milliseconds, grams to micrograms, centimeters to micrometers, grams per cubic centimeter to kilograms per cubic meter. Alright, so the first problem here is 15 cubic centimeters, and we're supposed to convert that to liters. So we need to know all the appropriate conversion factors first. So, cubic centimeters, you may not know this, but 1 cubic centimeter is equal to 1 milliliter. It's also equal to 1 cc, which is short for cubic centimeters. That's an old term that hospitals and doctors use. It's actually been phased out by the medical field as of last year. So you're not supposed to see that term anymore, but you might. So, goodbye. Now we also need to convert milliliters into liters. There's 1,000 of them. Now we can just start the problem. So 15 cubic centimeters are given or measured quantity always first in the top left corner times the first necessary conversion factor. Since we want to get rid of cubic centimeters, we use this one here, and so it's 1 cubic centimeter underneath 1 milliliter, and then we multiply by the final one. Alright, so first of all, cubic centimeters cancel out. We want to get rid of milliliters, so it's on the numerator right here, making it go in the denominator right there, and we have 1 liter. Your milliliters cancel out, leaving you with just liters. After you do this calculation, you will get 0.015 liters. That is 15 milliliters, but it wants it in liters, so 0.015 liters. Now you can take 15, put a decimal there, and you can move that decimal place 3 times because 1,000 is 10 to the third. And so 1, 2, 3. And you can see there's an empty space there, so you would put a 0 in. Your decimal goes there, and that's how you get the correct answer right here. The next problem is converting grams into kilograms. Now this one's pretty easy. You just have to realize that there are 1,000 grams in each kilogram. So we take 7.38 grams, and we're going to divide by 1,000 ultimately. 1,000 grams per each 1 kilogram. 7.38 divided by 1,000, you could write it out like this. You could move the decimal place 1, 2, 3 times, and you've got a 0, 0, your decimal goes there, and a 0 to the left. So 0.00738 kilograms. Okay. You could also have written the 1,000 as 10 to the third, and then the number of zeros here tells you that power there, which also tells you how many times the decimal place moves. Problem C here is 6.7 seconds into milliseconds. The conversion factor that you would need to use is that there are 1,000 milliseconds in each second. And so 6.7 seconds, that's our measured time. And we want to get rid of seconds, so 1 second down there and 1,000 milliseconds above. Seconds cancel out. And 6.7 times 1,000 is 6,700 milliseconds. Problem D here, 94.5 grams into micrograms. Well, you might need to look this up, but there are 1 million micrograms in a gram. Or you could say there's 10 to the 6th micrograms in 1 gram. Or you could say 1 microgram is equal to 10 to the negative 6 grams, or 1 over a million grams. There's so many ways to write these in the metric. Use whatever works for you ultimately, but you have 94.5 grams, what we're starting with. It's only a one-step process. So we want to get rid of grams when we want micrograms up here. And you can basically just choose any of them. What I would choose is I don't want to use fractions. So I would not use, whoops, I don't want to use that. I wouldn't want to use that one, and I don't like negative numbers, so I wouldn't use this one. Okay, which means this whole lineup of things is out. And so I would choose between these two. Personally, myself, I like exponential notation better because it's going to take up less space. So I would use this conversion factor. And so you have 10 to the 6th. What? 10 to the 6th micrograms. Sorry about the weight there. For every 1 gram. Your grams cancel out. And you could just simply do this problem. 94 times 10 to the 6th. 94.5 times 10 to the 6th is really 9.45 times 10 to the 7th, and it's micrograms. And there's your answer. And the reason why is that, again, scientific notation is always a number followed by the decimal. Here, you'd have to move the decimal over there. 94.5 is 10 times bigger than 9.45, so it makes the 6 go to a 7. Problem E is converting from centimeters to micrometers. Now, all the previous ones, A through D, used the base unit in one of the calculations, so they were pretty simple. This one doesn't. So there's 2 ways you could do it. You could go from centimeters to meters, and then meters to micrometers, or you could kind of do some work to do it more in one step. And so I'll show that way to do it. So first of all, there are 100 centimeters in 1 meter, but again, I like scientific notation, so I could say there's 10 to the 2nd centimeters in 1 meter. And then there are 1 million micrometers in 1 meter. But again, I'm not really going to use that. I'm going to use the scientific. 1 million is 10 to the 6th. All right. So now, what you will see, I'm going to write this out. We have 0.073 centimeters. So we want to first get rid of centimeters. So we're going to use this conversion factor here first. So 10 to the 2nd centimeters per meter. Your centimeters cancel out. We want to get rid of meters and go to micrometers now. So you've got 1 meter down there. and 10 to the 6th micrometers right here. Meters cancel out, and you're left with simply micrometers. Now, ultimately, what you get is 0.073 times 10 to the 6th divided by 10 squared. But we've got 10 to the 6th divided by 10 squared. We can simplify that into 0.073 times 10 to the 6th minus 2 power. Those exponents, since you have a fraction there, they subtract 6 minus the 2. And so this becomes 0.073 times 10 to the 4th. And that is the conversion factor, the 10 to the 4th, that goes from centi to micro. Since micrometers are smaller than centimeters, it's going to always increase the value of the number of the measurement, and it'll do it by 10 to the 4th or 10,000 times. So maybe you could write it as 0.073 times 10,000. Or you could move the decimal place 4 times. 1, 2, 3, and then a 4th time. There's an empty space, so you'd write a 0. And so really, your answer is 730 micrometers. All right. And the last problem in this set is 7.21 grams per cubic centimeter, converting that to kilograms per cubic meter. Now this is different from the rest of them in that there's 2 different types of units to begin with, and we're changing both of them. So we need to know, first of all, how many grams are in a kilogram. There are 1,000. And then, how many cubic centimeters are equal to 1, I guess, cubic meter? That's the tricky part of this question. So let's write this out. We've got 7.21 grams per each cubic centimeter. This is ultimately density of some object. What I would do first is get rid of the grams, convert it to kilograms, because that's the easiest thing. So 1 kilogram for every 1,000 grams. Or again, you could, and I would probably prefer to do that, write it as exponential or scientific notation, 10 to the 3rd grams. Grams cancel out. Now, we have to deal with the cubic centimeters. You know that there are 100 centimeters in a meter, or I could say 10 to the 2nd centimeters in 1 meter. So I could write that in here. Let's say 10 to the 2nd centimeters per each meter. Now the problem is when you're dividing, you've got centimeters there, and you've got centimeters cubed here. So really, that becomes a 2, and you have to repeat the process. So 10 squared centimeters per 1 meter. Let me rewrite these in here. 100 centimeters is 1 meter. Okay. Now, we can cancel that centimeter out with that 2 and write of 1. and repeat it for a third time. 10 to the second centimeters per 1 meter. And you have centimeters there canceling out not only that 1, which would make it a 0, but the whole centimeters ultimately cancel out. So if you look at it, we've got 10 to the second times 10 to the second times 10 to the second. You bring those together, ultimately you're going to get 10 to the 6th, because we got 10 to the second cubed, which is 10 to the 2 times 3, which is 10 to the 6th. So that leaves us with 7.21 times 10 to the 6th divided by 10 to the 3rd. For our units, we've got meters times meters times meters. And anytime you multiply something by itself 3 times, you get it cubed. So you get meters cubed there. We've got our kilograms there. So we have kilograms per cubic meter. And now we have 7.21 times 10 to the 6th minus 3, because you have 10 to the 6th there, 10 to the 3rd there, kilograms per cubic meter. And this is 7.21 times 10 to the 3rd kilograms per cubic meter, or 7,210 kilograms per cubic meter. Either of those options is correct. There's your correct answer.